So there's a bit of a walk around of the machine I've been building. So on my Z-axis we have 25mm vertical slides with a 25mm ball screw, direct driven with a 1200 volts motor. That's a lead shine easy servo. It's one of the closed loop. They're absolutely great. Inside, hard to see, you'll see right in there, or maybe not, but all the limit switches are all optical inside. For our X-axis, instead of having your two slides mounted here and say here, I've gone side and top. The reason for that is I can adjust everything back and up, so I've got complete adjustability for vertical to make sure that it's the same height across board and it moves the same way. Our X-axis is driven by a monster. It's a $2,800. This one's from Power Step. It's a non-closed loop, but it's try and install that. It's a very big motor. At the back we're running our tray. I've still got to build some bracketry here and clean this portion up. And then back to our drives, you'll see we're running dual Y-axis. The only design limitation I had with having the C-section was that it did allow for a little bit of flex, so I've gone and put in these big 20mm end stops and to make it a bit more rigid. I'm still working on the mount at the moment for the plasma head. It'll lean out and across. And this is our slave axis. All limit switches are all optical. Still working on bracketry here. Yeah, this will be done a bit neater. Same thing again. It's got the extra support in here. So the back of the machine, you see I've got these great big plates on either side. The idea of that is I want to put a tool changer, so later on I can bolt to those and I can have the actual tools sort of come up to this sort of level and change and then revert back down into a void which isn't used. Still working on the stand for the TV. Actually the whole thing I'm still working on. I'm still haven't, as you can see, it's turning temporary wide with just a proof of concept at the moment. Two big swarf catching trays for coolant. Spent a lot of time learning from the first machine I built that separating coolant and swarf, you really need a fair bit of fall on these. These have got over 15 degrees. Works quite well, and they come out and through two swivel joints into this bucket, and then this will pump back up to the head. It's a spindle itself. It's a 2.2 kilowatt water-cooled Chinese unit. Pretty impressive over the 8,000 RPM. Before that I can stop it by hand. It's got its own water-cooled tank. Currently it's just in the bucket, but it's got its own tank here. We have onboard vacuum and onboard air hidden under the cover, and into our box. So I'm using there's still a lot of wiring to be cleaned up, as I said, it's just a proof of concept. But using the hang-on VFD, it's a 12 volt PC for a vehicle that they use for GPS tracking. Vantec 1388, I think the model was, works really well. In the corner there's a board operator to turn the 12 volts back to 24. Because these Ethernet motion cards have 24 volt input. Bit of a pain in the arse though, actually. I wish they were 12. Two slave axes and a Z axis, so the lead shine in the blue colour, and that big monster, NEMA 34, runs this big. Actually, I can't remember the brand of that one. It might be lead shine as well. And then our power supplies. E-stop, something I never did on my first machine, which I wish I did. And as for the remote, currently running the 6-axis XHC. It's okay, there's a few dramas with it at the moment on step. If I use step rather than constant, it only drives the y-axis, it drops the slave off. And the operating system is Mac 3. Currently, just using another PC monitor. Just to give you an idea of how quick this thing will move. So it's fairly quick. It's doing about 9 meters a minute there. I can get about 7 out of the top. Probably wondering why the machine finishes so far in front of the actual the table. The idea is the table's 1300 wide by 1100, and then the 1100 itself will drop off, and I'll have on this section here a vertical table, so I can actually bolt things to it. For example, if I want to mill the end of that, I can bolt it that way, and I can also fit my rotating axis in that void, and I can also build an extension for the bed if needed. So there's 300mm of effectively non-usable space, but it is usable. The bed itself, I'm waiting on the material. It's going to be 20mm aluminium, and these posts, these will all get dropped in and welded in place. And that way it'll be square to that when I bolt to it. When I surface it, I should only have to take a milliscule off it, just a small amount. And that way I can unbolt the bed at any time and replace it, and also sit on top of the water bed for plasma cutting. And then the front bed itself, which will be a vertical wall, is 1200 wide by 750mm. On the top there's 25mm bolt separation, so 1400 bolts. I need to drill and tap with this machine just to, yeah, just a bit of an overlay of the machine I've been working on. I've still got to bolt the sides down. As you can see, I've gone through and put crush tubes in, all TIG welded. So the idea is you can actually unbolt the whole top section and move it forward or back 300mm each time. And that way, if you do have something that's in this big void section that I want to mill, it's actually say 600mm wide, I just move this whole top section out, and there we go. Alright, thanks for watching.